Hey guys, and welcome back to another video on the channel. In today's video we're going to be doing some student questions pretty much. So these are some submitted questions and I'm just going to be making a video on how to solve them. So pretty much we've got three differential questions here where we're just asked to differentiate the following function, and you can see they're all log based functions. Okay, so taking a look at the first one here, we can definitely see a lot of these guys are going to be chain rules. So this is your outside function and this is your inside function. Okay, so we need to know how to differentiate a basic log. Okay, so if we differentiate with respect to x, let's say natural log of, let's go f of x, and what we have to do pretty much is, alright, we know that the differential of natural log of just x would be 1 over x. Okay, so if we're differentiating natural log of f of x, this will be f dash of x, so the derivative of the inside function divided by the derivative divided by the regular function. Okay, so for example, if we had, like, say, natural log of x squared plus 1, this will be the derivative of the inside function. So if we differentiate that, that would give you 2x divided by your regular function, which would be x squared plus 1. Okay, so this one is no different, except when we differentiate this, we have a chain rule here, but we also have an overall product rule. Now when we're doing a product, we have to differentiate one function, leave the other, then we have to add, differentiate the other function, and leave the other. So in this case here, if we're differentiating this inside bit, we're going to have, so x plus 1 squared, and then 2x minus 1 to the power of 3. If we're differentiating this, differentiate the first one first. So bring the power down the front, so we have 2, and then pretty much leave the inside bit. Now if you differentiate this inside bit, it's just going to be 1, okay, because that has a coefficient of 1, and then you just multiply it by the leftover bit, so this will be 2x minus 1 to the power of 3. Then we have to do is pretty much leave the first function now, so now we're leaving this guy, and we're differentiating the next bit. Okay, so differentiate the next bit, bring the power down the front, so just go plus, put the first function, so x plus 1 squared, times by 3, minus the power, so I'm just going to move this stuff out the way very quickly. So we have 2x minus 1 to the power of 2, and then we have to multiply by the differential of this inside function, which would be 2. So simplifying this, we're going to have 2 x plus 1 multiplied by 2 minus 2x minus 1 to the power of 3. Then we're going to have 3 times by 2, which gives you 6, so plus 6, x plus 1 to the power of 2, and then 2x minus 1 to the power of 2 as well. So this is just the differential of pretty much this inside function here, which was a product rule. So if we're differentiating this entire function, it's just going to be pretty much all this on top of all this. So this would be x plus 1 squared, and then 2x minus 1 to the power of 3. And then we can literally just copy and paste this entire bit up the top. And if they asked you to simplify it, you probably would simplify it. So let's just go paste, and where did that go? That went down here. Make that a bit smaller, and just put it up there. Now you could probably factor out a couple things. So if we just move the entire thing down below, we could probably simplify this a lot better. So let's go down here. Now the only thing I can see that they all have in common pretty much is just these guys here. So we have that guy, and that guy. Now the most you could take out of the top is just strictly one of these terms, because there's only one term here, even though there's an x squared here, not x squared, x plus 1 squared here and x plus 1 squared here, because this only has one. The max you can take out is 1. Okay, so if you wanted to, you could probably reduce the power by 1 here, reduce the power by 1 here, and completely cancel that. Okay, and then we can also identify this bit here. So this is the same as this and this. Now because there's only a squared here, that's the max you can take out. So we can reduce this power of 3 to 1, reduce this power of 3 to also 1, and then fully cancel out this bit. Okay, so what we have left over is pretty much, alright, 2 times by 2x minus 1 to the power of 1. So we'll just write it like that. Plus 6 times by x plus 1 divided by x plus 1, and then 2x minus 1. And that's all you can probably do to simplify it. You could probably expand the top if you wanted to, but leaving it like that is completely fine. Okay, if you have any questions about what we've done here, leave something in the comments and I'll try my best to explain it. Okay, let's take a look at question B here. So question B is still a chain rule. However, when we're differentiating the inside function, it's going to be pretty much a quotient rule, okay? Because we have a function divided by another function, okay? Now, the quotient rule, it's very similar to a product rule, except the particular order in which you differentiate functions matters very significantly, okay? So give me 1 second, I'm just going to pull up a copy of the quotient rule, because I don't know this one off the top of my head. Let's go with this one. So you can write it in two ways. You can write it in terms of f of x or u. I personally prefer the u, so I prefer writing it like this, okay? So we can see here, this would be your u, and this would be your v, okay? So first of all, we're just going to try and differentiate this inside function, because the outside function is just going to be the differential on top divided by this function here. So if we go, alright, u equals 1 plus 2x, v equals 1 plus x squared. If we're differentiating this, it's going to give you u dash. Now u dash is the same as du dx, same with like v dash, that would be dv dx, etc. So u dash, differentiating this would just give you 2. V dash, just differentiating this would give you 2x, okay? So we can literally substitute this guy into here. What else do we use green here? This guy into here and here. And then finally, this guy can go into there. And then this guy can go into there, okay? So literally just copy and paste into the formula. So you're going to have 1 plus x squared multiplied by u dash, which is 2, minus 1 plus 2x multiplied by v dash, which is 2x, divided by just this function here, so 1 plus x squared, okay? Now I'm not going to expand anything just yet, just in case we can cancel stuff out when we differentiate the outside function. So this is just the differential of this inside function here, okay? So if you're differentiating this log, it's going to be your f dash on your f of x, okay? That's your f of x, and this is your f of dash up here, okay? So what we can do is literally just copy and paste this bottom bit. So we'll go 1 plus 2x divided by, what was it? 1 plus x squared. And this is going to be divided the other way. So we'll move this here, write a division symbol, and then we'll just copy and paste this whole thing here, okay? So let's see if we can cancel anything out before we simplify this. So we'll just chuck that there. There's a very long bracket. Let's squish that up. Okay. So the only thing I can see that is pretty in common is this guy, and this guy, and this guy, and this guy. However, we could probably change how this looks. So if you're dividing by a fraction, you can change that to a times, but you've got to flip this denominator and numerator, okay? So change that to a times, and just turn this guy upside down, okay? So that goes on top, and just move the bar, if I can get it, just there, and we lost the bottom of the 1, that's right. Alright, so we can clearly see, because there's multiplication, there's no addition on the bottom, you can clearly cancel out the green. So that and that can cancel out. You cannot cancel 1 plus 2x, okay? Because there's a minus here, okay? So they're two separate terms. If there was if this wasn't here, you could cancel that out as well. But because that's there, you can't do that, okay? So what we can only do is pretty much just write it like this. So 1 plus x squared times by 2 minus 1 plus 2x multiplied by 2x divided by 1 plus 2x. And you can't cancel the 2x either because of that plus there, okay? And that's how pretty much you would differentiate b here, okay? If you have any questions about that one, leave something in the comments and I'll try my best to explain it. But let's take a look at the final one, okay? Let's just snip it because it's getting very crowded up here. This one, it's alright. It's not too bad. Could be worse, could be better. Right. So differentiating this guy. So the inside function is this heap of garbage here, okay? Now this is a product and chain rule because we have a function times another function, but this is a chain rule, okay? And then this whole thing is a chain rule. So let's just differentiate this guy first. So x squared square root 3 minus 2x. So differentiate the first one. So differentiating x squared gives you 2x. Then just leave the second guy. 3 minus 2x. Now square root of something is that something to the power of a half, okay? So if we're differentiating this function here, you got to differentiate the outside, which is that half power. Okay, so first of all, write the x squared because you're leaving that. Differentiating this guy, you bring the power down the front, so in this case it's going to be times by a half. Still leave what's on the inside. Reduce the power by 1, so a half minus 1 is negative a half. Then multiply by the differential of this inside function, so negative 2. So we can see here that the half and the 2 can cancel out, but the negative sign will remain. Okay, so we can write this as 2x square root 3 minus 2x. And then we can just go negative x squared. And because it's a negative exponent, you can write that as 1 over, and that will be a square root. So square root of 3 minus 2x. Okay, so that's the differential of this blue bit here. Okay, so imagine you've got a dash there. This is pretty much that dash's result. Okay, and then remember, if we're differentiating a log, so if we have differential of natural log of f of x, that'll be f dash of x on f of x. So this is your f dash of x, which goes up here, and your f of x, in this case here, I chose blue again for that, that's alright. This is the differential of that. So this bit in here will go on the bottom, and this bit in here will go on the top. So we can just go, alright, let's just write that very quickly. So it'll be x squared square root of 3 minus 2x, all divided by this entire thing here. So let's just copy this guy. And let's see if we can cancel anything out. Now, even though it looks a bit messy, we can maybe cancel something out, because I can see there is one thing all these guys have in common. So let's just get rid of that very quickly. Let's move that a bit closer. And just to make this a bit easier on ourselves, let's change this back to a negative exponent. So we're going to change this back to 3 minus 2x, the power of negative a half, instead of writing it like this. Okay? Alright, now we can see every single term has one thing in common. It's this weird expression of that 3 minus 2x here. But to see what we can cancel out, we need to see what they have in common. Now, we can cancel something out. However, this is not the same as these twos here. Okay? But we can make it almost the same. Okay? Let's try and factor out an x. Well, we can factor out an x and this entire thing. Now, if we took out this term from the front, we're going to have x square root of 3 minus 2x times by 2. And now we've got to work out what we're going to place here. Now, you can only take out one x, so you're just going to have an x here. But if we think about this, if we're taking out one of these from this, what happens to the power? Okay, so let's think about this really quickly, or carefully. I would just take it. Okay, so if you have, let's just say x to the negative a half, right? And we have x to the positive a half. If you took out x to the positive a half, you'll have 1. But what would you have here? Well, if you multiply this with something here, let's say y, there has to be that result there. So in other words, we have x to the power of a half times by y gives you x to the power of negative a half. Okay? So if I were to move this guy across, I would have y equals x to the power of negative a half times by x to the power of negative a half. So if you're timesing two things with like terms, you add the indices. So negative a half plus negative half is just, well, x to the negative 1. Okay? So here, we have to replace this with 3 minus 2x to the power of negative 1 in this case here. Okay? Because if you were to multiply this back out to each of these terms here, this would produce the yellow guy up here. Okay? And then this would also produce this entire bit up here. Because if you had x times x, that gives you that x squared there. Then you have a square root times by the negative half. You have to add the indices, so that gives you that negative a half. Okay? So hopefully that makes sense. If it doesn't, try and leave something in the comments, and I'll try a better way to explain it. Okay? Then we have pretty much, we can factor out this on the bottom as well. So x square root 3 minus 2x, and we'll just have x here. Okay? And we can see that cancels fully with that because of the multiplication. So what we have is 2 minus x on 3 minus 2 to the power of negative 1 on x. then you could write that as a positive exponent. Doesn't really matter. You could probably leave it like that if you really wanted to. Okay. And that's about it. Hopefully those questions make sense. Again, if you have any questions, leave something in the comments. But I'll see you in the next video.